Today we'll learn how to use traces so that our snot can spread and then punch it out of existence. Starting with some explanation, ray traces, or sometimes raycasting, is a way to trace out a line in the 3D physical world, starting at a point and ending in another. Once we run the trace, it will check for any collisions between point A towards point B. If it hits anything solid, it will return what it collided with, the position where the collision happened, the type of surface, and more. Think of the fancy ray tracing you see in video games. All it does is shoot millions of these from the camera and rendering whatever color it hits. There's much more to it than that, but let's not get ahead of ourselves. We're not just limited to tracing thin lines, we're also able to define a thickness, a shape, or even which tags it can or can't hit. For example, we can assign enemy and ally tags to our players, and to disable friendly fire, we just ignore anything with an ally tag. You may have guessed it already, but we'll be using these tags to detect if there's a snot in front of us when punching. If there is, then it gets damaged. But before that, let's give them a way to fight back. Our snot needs to multiply itself over time, and when it takes over the spawn, it's game over. But we can't just make copies, move them around and call it a day. What if there's a wall to the side, or the snot is in a corridor? How will the player fight something behind a wall? And what happens to our performance once there's 5000 snots outside of the map's bounds? I think you get the point. We run a few traces around the snot and see if there's enough space to place a clone there. Right, let's get to coding. Open up our snot prefab, and let's create a new component called multiply component. Let's start off with a property to define how fast it multiplies, and instead of just a float, I'll use a ranged float. This way we can pick a random interval. In our case, the default will be 2 and 3 seconds. If we had every snot multiply at the same time, then the player will get noticeable lag spikes every 2 seconds. By choosing a random interval, they will multiply at different times, spreading out the spikes into an even performance jam. Let's also add a property to reference the snot prefab. You can treat prefabs like a game object and it will still let you select and clone them. But to remove any confusion, I'll replace this with the proper class. Prefab scene. This way you are forced to select a prefab and not accidentally drag in a game object from the scene. But why not just clone the snot itself instead of a prefab reference? Well, yes, we could, but then we would copy over the snot's health and properties. Maybe we did it while it was red and now the clone is red forever, or tiny, then we'd have to reset all of those and it just gets messy. It's easier to just create a fresh new clone from the source prefab instead. Right, enough explanation. Create a new method, I'll call it multiply. And now let's set up a timer to call this method. I'll do it inside of onFixedUpdate since it doesn't need to run every frame. Create a time until field like we did last time. And this time we'll set it to 3 seconds so it doesn't immediately clone itself. Once the timer is up, we'll call the multiply method and reset the timer to our cooldown. We could manually get a random number between 2 and 3, but ranged float already comes with a method to do that for us called getValue. And now if we play, you can see it's printing in the console at random intervals between 2 and 3. Except at the beginning, because we hard coded 3 seconds in. Let me actually change that. There, now we already set the timer to a random interval inside of the onStart method. Okay, well now I'll get comments about how this encourages bad programming practices, so I'll make a private method to reset the timer and replace these 2 lines. There we go, it's time to finally trace some rays. We'll start off by picking a random direction around the snot, and since our levels are flat, we can ignore the z-axis and focus on the x and y. There's multiple ways to do that, I'll show you 2. Get a random angle between 0 and 360. Create a rotation using that angle as the yaw component. And then get the forward direction, otherwise we can directly get a random vector tree with this method. This actually returns a vector 2 which only has the x and y, but since we don't care about the z-axis, we can just cast it into a vector tree. and normalize the result to make sure it's directional. Difference being that a normal vector represents a point in space, while a directional vector tree represents just that, a direction, and has a magnitude, or length, of 1. Rotations and directional vectors kinda represent the same thing, that's why earlier we got it from a rotation, just like how you can do the opposite with this. But let's get back on track. We'll need a starting point for our trace. I'll use this snot's position and offset it upwards by 20 units, otherwise it starts in the ground. Then an end position, 100 units away from the start, going towards the direction we defined earlier. Lastly, we can finally call our trace. Scene, trace, ray, start pose, end pose. A ray starting from our start pose to our end pose. A common mistake I see is this. Treating the second parameter as if it was the distance you want your trace to travel. It's not! If you need it set up like this, you can pass a ray, just like this, where you define the start position, the directional vector, and then we define the distance. But I'll stick to my method. We're not done with the trace yet. This is a trace builder, as we are still building our trace. We could run our trace already, but that won't give any good results. Start off by defining the thickness of the trace. A radius of 10 should be good. You don't need to define it, but I don't like my traces to be too thin. Ignore anything with a player tag, we don't want them to be able to block the progress. In fact, later we'll have it so that you die if a snot is spawned on top of you. We're not gonna ignore other snots, otherwise they'll just keep spawning on top of each other. Actually, let me make sure we do have a tag on the player prefab. And nope, we don't have it. Let's add one real quick and save. Go back to the code. Next up, we want this trace to ignore the snot's game object and all of its children. Otherwise, it's not gonna make it that far. And finally, run our trace. Why did I format it like this? Well, it's more readable. Look at how ugly it would be if it was in a single line. Yuck. After running the run method, instead of getting the usual trace builder, it returns a trace result instead, having simulated a trace with all the specified requirements. With this trace result, we can see if we hit something. If it didn't, then it means we're free to place a snot. If the trace didn't hit anything, clone the prefab at the end of it. We move it down by 20 units because earlier we moved the trace up by 20 units, this way the snot is placed on the ground. Make sure to use the trace end position instead of the hit position, which returns where the trace made contact. In our case, it wouldn't return anything since we made sure to run code if it didn't hit anything. Let's add a check at the beginning to make sure the prefab is valid, or else we'd get an error here. There we go, let's try that in game. Look at that, they are spreading, but within the map's bounds. I'm not sure why they are tweaking like that when spawning, maybe something to do with how the anning graph is set up. Let me sweep it under the rug real quick by making units fade in when they spawn. I'll go back to the unit component and add a new time until and set it to 1 second from now. Go inside of the onStart method and make the unit invisible. Guess I should also check if the model renderer is valid, just to be safe. Then inside of onFixedUpdate, if the timer isn't up, set the model's alpha to the timer's fraction, which always returns a number from 0 to 1, 0 when the timer started and 1 when the timer finished. You know what, I'll also make it so that you fade out on death. Add a fade out field. Set it to 1 second inside of the death animation. And then, when the unit isn't alive anymore, we set the alpha to 1 minus the fadeout's fraction. That way it will fade out on death. I gotta modify this check up here since we do want to run this code when it's dead. Just run it if the unit is currently alive. Let's try it out. Yes. Looks pretty nice. Let's also try it on the player when it dies. Oh, right, it's a prefab. So we want to unlink it from the prefab if we want to access it first. Let's just add in our unit components onStart method this line of code. GameObject break from prefab, so that when it spawns, it will automatically unlink it from the prefab. Let's try it out now. Whoops, I guess I gotta reset it when it respawns. Set the tint with alpha 1 on side of our respawn. Let's try again. Perfect. Enough with the side tracking now. I said we'd kill the player if it is not spawned on top, so let's do just that. Let's go back to the multiply component, and inside of the onStart method, let's take a look at something similar to traces. FindInPhysics, which returns a list of game objects. As opposed to traces, FindInPhysics doesn't have an end position, you can only define a sphere or a box. It then finds any game object with collisions in the area. It doesn't have to be completely inside, it finds anything touching the edges too. You just have to remind that this is called FindInPhysics, not FindInCollisions, meaning that anything that has been marked as static won't be returned, like the map or background props. Find any object inside of a sphere located on our snot position with a radius of 100 units. Loop over all the game objects it found, and if the game object has a snot player component, this returns true and provides us with the component. In our case, we defined it as a variable called player, which we then kill through its unit component. Save and try it out. I'll stand near this knot and see what happens if one gets cloned on top of me. I'm kinda scared. Whoa, there we go, I'm dead. Maybe a bit overpowered. What's the point of having player health if you instantly die? I'll have it deal 50 damage instead, and then destroy itself so the player doesn't get stuck inside of this knot. Alright, good enough. We'll add particles in the future for better feedback. Looks like this knot has the upper hand right now. It's time for us to fight back. Let's start off with a punch method in our player component. And we'll set it up similar to how we did with this knot cloning process. Start off with the direction. In our case, the default player controller comes with the property eye angles, which returns the direction you're looking at. Oops. And then we set up a start position. Again, we can use the controller's eye position, so we're shooting this trace from our eyes. And our end position will be the start plus the direction times 100 units. Or even better, let's set up some properties for the punch range and damage. I've gone ahead and put these two properties inside of a category called stats, so we have punch range and punch damage, with some cool sliders as well. Go back to the punch method and multiply the direction by the punch range instead. Now let's build our trace. A new ray trace, starting from the start position ending in the end position. With a radius of 20, so you don't have a hard time aiming. Ignore the players. Ignore ourselves, kinda redundant since we are a player, but it's good practice. And run the trace. This time we check if the trace did hit something. And if it did, we see if the game object with it contains the unit component. And finally, if they are an opposing team, we damage them by our punch damage. I bet some people are shrieking at how this code is formatted, so instead of stacking if statements, let's do early returns. Escape if we didn't hit anything. Escape if it doesn't have a unit component. Escape if we are on the same team. And finally, if we pass all those checks, we damage the unit. You can code however you want really, this is just cleaner, I guess. Anyways, we can't really go far if we are not calling this method anywhere, so let's do it whenever our player presses the left mouse click. Let's go inside of our onFixedUpdate method and check for the input. Input pressed attack 1, which will return true during the frame. We also have input.down, which will always return true as long as the button is being held down, and input released, when you finally let go of the key. There's more useful properties to the input global, like input analog lug and input analog move, returning mouse movements for the former and WASD or joystick movements for the latter. Thankfully, the default player controller handles those for us, but they're pretty simple to implement. You might be wondering, where did I get this attack 1 from, and why not mouse 1? Well, that's because I'm not using button names, I'm using input names, and those are defined in your project's settings. If you go up here to project and settings, then to the input section, you can see all the inputs defined by default. We have our movement, was to move, space to jump, shift to run. The actions and attack 1 is set to mouse 1 or left click, but it's also set to right trigger for controllers. That's why we use inputs and not buttons, so that our game can support every type of controller the player uses. In fact, if we scroll down, we can find the supported control modes in your game. Let's just stick keyboard and gamepad, since they're set up for us anyways. Not VR though, I haven't tested it. You can also modify, remove, or add inputs of your own. Just don't modify the name of the WASD keys. I think the names are hard-coded so that input.analogMove can work with joysticks. Actually, over here we have the view button bound to C, so if we go in game and press the C button, it switches from third to first person. That's still the player controller's doing. While we're here, let's try out punching, shall we? I'm pressing left mouse button and this knot is getting damaged. Oh. Since we used eye angles and eye position, we can switch to first person and it still works. We're punching pretty fast right now. Let's add a cooldown. I'll add a new property to define the punch cooldown, and maybe in the future we'll have upgrades so that you can punch harder and faster. A next punch time until, actually I think I'll make this public, so that we can access it in the future if we want to implement it in our UI. Wait for the cooldown to be up, then punch and reset the timer. Let's try it out. And now even if we spam left click, it will wait. I can probably see the clicking getting annoying in the future, and I don't want to strain my gamer finger, so I'll switch it so that you can hold down the button. Just change input pressed to input down. Since we have a cooldown already, there's nothing to worry about. Ah, much better. All that's missing is the animations. Just like we did in the earlier episodes, let's have a look at our player's animation parameters. In the citizen's case, what we're looking for is the b_attack boolean, b stands for boolean, and the hold type enum. We want to set the player's hold type to the punch pose, and when the player presses left mouse, it plays the punching animation with the b_attack boolean. Let's set those up in the punch method. Before all of our checks, since we want to play the animation even if we miss, set the hold type parameter, and enums are treated as integers, so we'll have to see which one is the melee animation. 0, 1, 2, 3, 4, 5. So we'll put in 5. Then we set the b_attack parameter to true. To play the punching animation, save and try it out. We can finally settle our beef with this knot. Take this and this. Oh, I'm dead. I guess they win this one. We're almost done. I'll abuse time until one last time to set the hold type back to the default one if we haven't punched in a while. A reset pause field. If it goes off, we reset the hold type to 0. And when we punch, it resets the timer back to 3 seconds. Perfect. Now we can still admire the running animations and punch our way through this knot. That's it for this episode. I hope you truly understand time until now. Thanks for watching and stay tuned for the next episode.